Okay, Math Cluster Junior. So we got a few little things I'm going to go ahead and do to round out the year. We only have like 2 weeks, I think, left, something like that. So we're almost there. So today we're going to go ahead and do equation of a circle. The idea today is I'm going to give you 3 points, and you're going to find the equation of the circle that goes through these 3 points. This is actually a variation of a topic that we did. It's been a while. I know I gave you guys a couple of points, and y'all found like the equation of quadratic, for example. And I know we did linear as well, and least squared curves. So it's a variation of that. So what I've given you guys are 3 points, 1, 7, 6, 2, and 4, 6. And what we're going to do is we're going to set up a matrix, a 4x4 matrix, and find a whole lot of determinants. Not too bad. So the first column of our circle matrix every single time, because it is the equation of a circle we're talking here, our first column is going to be our x squared plus y squared terms. So we're going to go ahead and fill column 1 out. Second column is going to be just our x's. Third column is going to be y. And the fourth column is going to be our constant, which is ultimately going to be a part of the radius. In general, the equation of your circle, generic circle, is x squared plus y squared plus x plus y plus constant equals 0. So that's kind of where this equation comes from. So to fill out column 1, x squared plus y squared, I have it written out here to the right. So we'll start with the first point, 1, 7. So 1 squared plus 7 squared is 50. Put it right there. 6 squared plus 2 squared, call it 40. 4 squared plus 6 squared, call it 52. Put it right there. X column is just simply the 1, the 6, and the 4 going straight down. That's your x values. Y column is just simply the 7, the 2, and the 6 going straight down. And our constant, since it doesn't have x or y, is just 1 going straight down. So not a big deal there. So what we're going to do is we're going to do cofactor expansion across the first row. It's going to require us to define 3x3 determinants. Not that big of a deal. The one thing you're going to have to watch out for is keeping a track on the signs, but we'll make sure we clear that up. So now that I have my matrix here, I'm going to go ahead and expand it across row 1. And I am going to go ahead and start right here with row 1, column 1. So if you sort of think back to what we did before, I believe what we basically said, we're going to go ahead and expand across this row. And I'm going to go ahead and start with row 1, column 1 like this. And if you remember, that leaves us with the minor matrix. So our minor matrix in this instance is going to be 1, 7, 1, 6, 2, 1, 4, 6, 1. So we're going to go ahead and get that determinant. After we have found that, we'll go ahead and shift over, and we'll go ahead and find our, we'll do row 1, column 2, and then row 1, column 3, and row 1, column 4. But we'll start here. So now that's what we're going to do. So there is our minor matrix. And if you remember, the quick way I gave you guys of doing this is you take the first 2 rows and you write them on the outside of the minor matrix. And then you simply draw your diagonals and you add going from left to right, and then you subtract going from right to left. So I did 1 times 2 times 1 is 2. 7 times 1 times 4 is 28. 1 times 6 times 6 is 36. Minus 7 times 6 times 1, 42. 1 times 1 times 6 is 6. 1 times 2 times 4 is 8. So when I do that, I get 66 minus 56, which is 10. Now, one thing I also want to note is we are using element 1, 1, and you do have to keep track of your signs, because sometimes we're going to have to flip the signs depending on whether it's a positive or a negative element. So in this case, if you remember, we always did negative 1 raised to the sum of the element power. So negative 1 raised to the 1 plus 1, that's just negative 1 squared, which is positive 1. You do not flip this sign. So there it is. So now the next one, we're going to go ahead and go across row 1, column 2. So if I just kind of come back up here, essentially what I'm going to do here is same idea, except we're going to use now row 1, column 2. So that's going to leave me with the minor matrix of 50, 7, 1, 42, 1, 52, 6, and 4. And I'm going to do this for all of them for when I get my minor matrices, but that's just how I shift over to get the next one. So my next one, there it is. There's my minor matrix. I do want to make a note that this is going to be negative 1 raised to the 1 plus 2 power, which is negative 1. So once I find this determinant, I have to flip the sign, and I have done that. Just like I did last time, I wrote the last 2 columns out there on the outside. and I did my multiplication, did my subtraction. I get 20, flip the sign to negative 20. So I have done that. Moving my way down the columns. So now I'm going to do row 1, column 3. So there's the math on that one. I want to make a note that 1 plus 3 is 4, makes it positive 1. Do not flip this sign. So once again, I drew the columns on the outside, multiplied the diagonals, added them up, did my subtraction, and I got negative 40. Same thing with the last column, not a big deal there. This one I am going to have to flip. 1 plus 4 is 5, which gives me a negative 1, so I'm going to flip my sign at the end to negative 200. So once again, both the first two columns on the outside, multiplied, added, subtracted. I got 200, flipped it to negative 200. In general, folks, as you go across, you will not flip the first one, flip the second, do not flip the third, flip the fourth. I mean, that's just kind of how the pattern works. All right, so here's my equation. I have 10, 10 times x squared plus y squared minus 20x minus 40y minus 200. To make things a little bit easier, I'm just going to cut off a 0 out of everything. So that makes things a little bit quicker for me. I will distribute the 1. Obviously, distributing the 1 in the front doesn't change anything, but nevertheless, has to be done. So I get x squared plus y squared minus 2x minus 4y minus 20 equals 0. I will move the 20 to the other side and make it positive 20. And I am going to apply my complete the square. So I'm going to complete the square on this one. So I'm going to go and get my terms together and complete that square. So x squared minus 2x. As a reminder, to complete the square, I'm going to take half of negative 2, which is negative 1, squared, which is positive 1. And then on the y, so I have y squared minus 4y. Half of negative 4 is negative 2. Negative 2 squared is 4, so hence plus 4. And then don't forget that I need to add this to both sides of my equal sign. So I will do that real quickly. And change that real quick. I don't know why I put a 5 there. So let me change that to a 4. There we go. Okay, I got that fixed. So there it is as a 4, like it should be. And then I have, once I complete the square, x minus 1 squared, my y minus 2 squared equals 5 squared, which tells me the radius. So this is going to be a circle with a center of 1, 2, and a radius of 5. So basically what I'm asking you guys to do is to tell me the equation of the circle, complete the square, give me the center, give me the radius. If you guys need any help or let me know. I will gladly host online stuff if you need it. I don't think this assignment is particularly bad. It's just a little bit tedious having just to do all the number crunching. So make sure you do get this complete, folks. We really only have a couple of weeks left, and then we will be finished for the year. And then I'm working on grades and getting all those updated. And so if you need anything, let me know, guys.